Hello everyone, this is Hw2 from the class EL6303. In this video, I will solve the question 5 of homework 2. First, I will set A means in 2 minutes, at least one customer will arrive. And not A means in 2 minutes, no customer will arrive. And we also know that the probability of not A equals to 1 minus the probability of A, and which is 0.7. Because the customer flow at this grocery store can be viewed as a Poisson process. That means the probability of the number of customers arrive in the interval between 0 to t, which is k, should have an equation. That is e to the power of minus 2 times lambda times 2 times lambda to the power of 0 and divided by 0 factorial equals to 0.7. Through this equation, we can get lambda equals to minus a half times ln 0.7, which is roughly equal to 0.178. So this is the answer for question 1. Now let's look at the question 2. In this question, we need to find that the probability in 3 minutes no customer arrive. In this question, we still use Poisson distribution formula as question 1, but in this time we plug t as 3. Lambda is 0.178 and k is 0 to the Poisson distribution formula. Then we can get the answer is equals to 0.586. Now, let's look at the third question. In this question, I will set B means in 10 minutes, at least 2 customers arrive. And not B means in 10 minutes, less than 2 customers arrive. For not B, there are 2 situations. One is that there is 0 customer arrive in 10 minutes. And the second one is just 1 customer arrives between 0 and 10 minutes. Then the probability that not B equals to the probability that in 10 minutes 0 customer arrives plus the probability that in 10 minutes just 1 customer arrives. To figure out this equation, we also need the Poisson distribution formula. So the probability that in 10 minutes there is 0 customer arrive should be e to the power of 10 minutes times 10 times lambda to the power of 0 divided by the 0 factorial plus the probability that just 1 customer arrived in 10 minutes, which is e to the power of minus 10 times lambda times 10 to the power of 1 and divided by 1 factorial. And this equation roughly equal to 0.47. Moreover, because the event of B and not B are mutually exclusive, that means the probability of B equals to 1 minus the probability of not B, and the answer is 0.53. And for the last question, let's look at question 4. We need to find the probability that in 1 minute, exactly 1 customer arrive. That should equals to the probability that the number of customer arrives between 0 to 1 equals to 1. We also apply the boson equation to it. Then it equals to e to the power of minus lambda times lambda to the power of 1 and divided by 1 factorial. This equation roughly equal to 0.15. Here is the final answer for question 4. Thank you.